name is Kevin Duke, and I'm an analog applications engineer here at Texas Instruments. Today, I'm going to explain the basics of device damage and transient immunity. This is your new and pristine TI IC, and this is your IC after it's been exposed to EOS, or electrical overstress. EOS refers to any voltage or current that violates the absolute maximum specifications for a given device. Typically, the root cause of EOS damage is triggered by a device's ESD protection cells, which are intended to handle low power events. And the figure on the screen illustrates a generic I/O pad with ESD protection. Clamps 2 and 3 protect the input stage and can be thought of as diodes. If a transient occurs with sufficient voltage and current, these clamps will forward conduct. When these clamps conduct, the device may be damaged and show parametric degradation or a total lack of functionality. In industrial applications, you need to protect a device from these transients to enhance reliability. A test standard called IEC 61000-4 simulates these EOS events and awards a certification to products that prove to be immune to transient EOS. It begins with the electrostatic discharge or ESD immunity test called IEC 61000-4-2. This test simulates the electrostatic discharge of an operator directly onto an electronic component. To simulate this event, an ESD generator applies ESD pulses to the equipment under test, or EUT, either through air discharge, as shown in this photo, or through a vertical or horizontal indirect coupling plane, as shown in these two photos. Characteristics of this test are the short rise times, short pulse duration of less than 100 nanoseconds, high voltage, up to 15 kV, and low current. This test requires a minimum of 10 discharges of each positive and negative polarity. Many equipment manufacturers consider ESD test the lowest priority of all tests since its occurrence is limited to installation and maintenance work on I/O modules. During these activities, operators should wear ESD protective clothing and intentionally discharge themselves prior to any contact with the module. IEC 61000-4-4 is the burst immunity or electrical fast transient test. Many manufacturers consider this test the most important as it simulates everyday switching transients found in the industrial application space. It is performed on power, signal, and earth wires, or a subset depending on what is appropriate for the EUT. In this test, a burst generator produces a series of bursts lasting 15 milliseconds with a pulse rate of 5 kHz. The time between bursts is 300 milliseconds. These signals are introduced to the system via a coupling trench, as shown here. Significant properties of this test pulse are its short rise time, the high repetition rate, and energy content. Though an individual EFT pulse peak voltage is only 4 kV compared to the ESD pulse of 15 kV, an EFT pulse delivers more than twice as much power. Moreover, this test requires the application of 6 burst frames of 10 seconds duration with 10 seconds pause interval between each frame. The entire EFT pulse train delivers 4 orders of magnitude more energy than the ESD pulse. While the surge immunity test, IEC 61000-4-5, is the most severe transient immunity test in points of current and duration, its application is often limited to long signal and power lines of length greater than 30 meters and high voltage systems who output or input greater than 60 volts. This test simulates switching transients caused by everyday lightning strikes or the switching of power systems, including load changes and short circuits. Characteristics for this test are the high current due to low generator output impedance and the long pulse duration, approximately 1,000 times longer than for ESD and burst tests, indicating a very high energy pulse. This test requires 5 positive and 5 negative surge pulses with a time interval between successive pulses of 1 minute or less. This photo shows the setup for a surge immunity test. Large isolators are used to protect supporting equipment, such as multimeters and power supplies, from damage during the test. Any system that is not permanently damaged from exposure to these tests receives a passing result. Units that do pass the test are awarded results that fall into various classes. Class A systems perform within a specified error band even while being exposed to the transient signals. Class B systems exhibit degraded performance during exposure to the transient but recover automatically. And finally, Class C systems require external interaction to recover from exposure to the transient event. In conclusion, understand and leverage the 4 basic properties of all of the IEC transient signals to deliver robust immunity to your system. They are high voltage signals and high frequency signals that may be repeated and may deliver large current. For more information, please visit the following URLs.